So there's a results manager. There's two parts to this manager, similar to subject, how you have your subject data and you also have the background stuff that you set up beforehand with different attributes that you're creating or collecting. So for results manager, there's the results information. This is the actual data that you've collected. And there's also the procedure definition. This is how you set up your procedures or experiments beforehand. And when you set them up, you have different components or properties of the procedure. So I'll look at one that's already created. This is for a Hologic Invader HPV test that we're doing. So the name is the manager procedure. These are set up by institution, so they can be shared across repositories as long as the users are at the same institution. A required field is the assay type. This is some examples would be if it's research or diagnostic. I'm sure there's other types of assays. An assay is another word for a test or procedure experiment. So this is a research assay. The platform would be something that the users should know. I would hope this is sort of the basis for your test. An analyte would be something that this is optional, can be entered by the user setting up the procedure. If a calibrator is required, this will let the user know that they should run a calibration run for their experiment if there's some sort of machine that needs to be calibrated before actual results are collected. A standard is a specimen or set of specimens that are tested that all of the other specimens are compared to, so that everything that's run at the same time is subject to the standard specimens and what their values are. So if the standard is required for a procedure, you could check this off. Software specification, that's the software that the test is being run on. Usually aren't manual tests, they're done with different machines. Owner is defaulted if you created this, that you could change it. Assay setup type is pretty important. The two options are input mapping or vial order. Input mapping means that you're testing the specimens on some sort of grid or well plate, and they're, the specific locations will be captured. Vial order means they're being tested one at a time or sequentially. And that's important for noting the locations of the specimens within the results data. Okay. Modifiers is just anything else that you want to track about your procedure. And then we have run properties. So a procedure is the general test that you're doing. A run is an individual execution of that test. So if I'm taking 100 vials and testing them right now, that's a run. If I test them again later on or tomorrow, that would be a separate run. So run properties are information that you want to track about each run of the experiment. So the default ones that are set up will be the start time and end time, and whether you're using input mapping or vial order, you can specify the input mapping vessel. And I said I'll be using a 96 well plate to test my samples on. Or you could enter the default number of specimens. These are just defaults and they can be changed later on. And you can also add new properties. Adding fields or properties is the same as it works in subject or customization, where you add your fields, you pick the field name. If it's a required property, the description, the field type, and if it's active, and then you have value properties based on your field type. I don't want to go too deep into that, since a good number of you on the phone already know how that works. If you have any questions, I'd be happy to answer them still. So your run properties, again, these are the default run properties, and you can add more run properties that you want to collect for your procedure. So I am setting this up with a particular procedure in mind. If you're running your experiment with some sort of machine or software behind it, it will spit out a data file, and your procedure should be set up with that data file and the information that you want to collect in mind. So I have these run properties that are automatically generated with my file, and I want to capture them. So I set up fields for the data file date stamp. So that's at the top up here. The operator and the raw data file name. So these three properties I'm interested in keeping around. The date I'll just put into the existing start time at the top, or one of the default fields. So does the run data make sense so far? Anyone have any questions about that? Okay, so the next level, we start off with the big picture and then we get more granular as we go. So run properties are, you could think of these as like batch properties or requisition properties, sort of at that higher level. And then the next level down would be your specimen data, the specimen result data. So you can set different data tables. This particular file has 2 tables in it. Full disclosure, I added this one on my own just so we could have an example of both. So there's 2 different data types or data tables that can be handled through the results batch or the procedure. The first one is your standard table, where each row represents one specimen or one test vial or well, and each column represents a different piece of information that's collected. So in this table you have, this would be your vial that's tested, and we're collecting the SPAM signal, the red signal, SPAM at fluid ounces. I'm not 100% positive, but each of these columns is what you're collecting or what's being spit out by the machine. And we just call that a table for simplicity. Then the other type of data that could be spit out is grid data. And this is where you have a table that's returned, and within that table there's one piece of information that's collected, and the way that we know what vial it belongs to is based on the mapping location. So this is, we know that the vial that's in A1 has a result of red. So this is what we call a grid data set. So when you set the data sets up in the procedure definition, we're setting up the data that we're expecting to be returned by our Excel file. So for our first table, it's this one at the top, this in-data data analysis, HPV. And I'm adding in the fields that we're collecting. So the BSID is, that's by default going to be collected, so we don't need to add that in. So we have our SPAM, FOV, and the ratio of the signal, the red. So we first set up our data tables. I have my first table here at the top, which is just your traditional table where you have each row can contain multiple pieces of information for one individual specimen or iteration of a specimen. And then I have another data set here, and this is called my color grid data set, and that's representing the bottom table, the one with the colors on it. So for this sort of data set, you can only have one field since there's only one piece of data that can be held in that table. And then for the top section, I added a verifier. This is, again, the same as customization or the subject module, where your verifier can be set up based on the fields that you have added. And the one addition here, I don't think this is anywhere else, is the weak error. And this is more serious than a warning, but not quite as severe as an error. So you can save your data if you have a weak error. A regular error, you cannot actually save your data. Any questions about the different data sets and setting that up? The first part with the procedure and the run properties, this is all input information that we know beforehand for the most part, maybe not some of the run properties. And then we're setting up the output at the bottom section. I guess if that clarifies it a little bit. Okay, so things that are unique to result batches, you can set up controls. A control is a verifier that would apply to a specific specimen, and when you are actually entering your results data or executing this in requisitions, you can specify which specimen that is. And the point would be to know if your data is valid based on expected information from this control specimen. So this could be like a glass bead or water or just something that you know what would come out of the machine. So I have this throwing an error if my value is not in between 1,000 and 1,100, meaning that my expected value is between those two. Standards, again, are certain vials or specimens that you want to compare your entire results data against. And you could set those up. They would just be individual values. You could call it maybe standard A, standard B. And then characteristics are anything else that you want to capture about your specimen. This could be the dilution factor, if there's any sort of reagent that's used, any mixture. This data file had a field called mix, so I interpreted that as a characteristic, some sort of manipulation has been done on the vials that we want to capture in our results batch, just so we know that this data can only be used in the context that the mix had been applied. Okay, so you can save your batch, or sorry, your procedure, and there's two steps to creating the procedure. Somebody needs to create the procedure, and then somebody can review it and release it. And a procedure can only be used once it's released. You could, once you have your procedure set up, you could go straight to the results manager and add data. If there's a data load that users want to bring in from a lot of historical data, they could just do this. If they're not the ones who are actually testing the specimens, they could just come straight to the results batch and enter the data. Just like with everything else, users should really only use requisitions to track work that they're actually doing. So if they're not the ones completing the assays, they might not want to go through the requisition process. So they could just come right into the results batch and add in their data. But we'll come back to this. I'll just go through the requisition part of it. So I created a requisition with my samples that I want to test. I already added one test, but I'll just add on another. There's a procedure test. That's what should be used for executing a procedure on particular vials. So part of the test, you need to select the procedure. All of the release procedures will be listed here for my institution. And if I want to add this data to an existing batch, I can enter my batch ID, or I can just create a new batch, which is what I'll do. So this is a two-step task completion, just like aliquots or process tasks. So the first step is executing the assay. Now this is when we enter our run information and any mapping data that we might have. So a run label is just how you identify the run. This could be sequential. It could be the date in some sort of sequence. I'm just going to use one. Input mapping vessel is the size of the well plate that you're going to use, or the grid. I'm using 8 by 12. And we have our other fields here that we added in from our procedure definition. If you know this information now, you could fill it in, or we can import it afterwards. We probably won't know we wouldn't know the data file name just yet. So if you press next, you have your control information. If you need to change the min and max values of your controls, you can do that here. Or we can just press next if we want to keep the control limits as they are. Okay, so since we said this was an input mapping vessel or a grid, a well plate, we have our well plate configuration at the bottom. If we had said vial order, it would have just been one column with however many vials we said we were going to test. So the vials can be dragged down here one at a time. You could drag all of them. You could drag them in multiple locations. So if I were going to test the same vial twice, maybe I would have different mixtures or different solutions. I can do that here and don't need to create them as individual vials with their own BSI IDs beforehand if that's not something that the lab would actually be doing. Usually they just put different amounts in the well plate and test it multiple times rather than officially creating new vials or records for those specimens. So I'm going to drag all of these down. Okay. And it fills them all in here. If there are any controls, you can mark which particular vial is your control. So I'm going to mark this first one as my control, which I called target solution. And for any characteristics, you can set those up here, or you can import that information. So perhaps this row has mix A7, and this one has mix A5, A6. You can set that up. So by default, we're viewing all the information. If we just want to see the mix information, we can change our view to just show that. And all of the mapping information that's not vial specific can be saved. So what's this invader? We can save it and then load it the next time. So that would be saving your control. typically the controls are always going to be in the same spot. If it's common that the first row would be an A7 mix and the second row would be A5, A6 mix, that would be something that's saved. And then you could load that in, and you wouldn't need to load that each time you execute the assay. So for tomorrow we're testing a new set of vials. We wouldn't need to map that again if we just load in our mappings from this time. And you also have a vial order here. So if there's a vial order set up in the requisition for this task, you can use that to sort and pull the vials down to the bottom section. Okay. Are there any questions about this executing the assay through a requisition or beginning this task?
I have a question. One of the people that I worked with had like a mapping of the fields already.
Uh-huh.
And they wanted to like import a mapping.
Can
you do that?
There's not an import option here.
Okay.
Were they importing like this vials and
like this
one?
And
yeah, there's not an option to do that.
Okay.
But you could, I guess you could use that to set the vial order and then use the vial order to pull the data down to the bottom.
Yeah. Can you edit that vial order from there?
From here, no.
Where do you enter the vial order? From the
task.
Oh, okay. Okay.
Yeah, and you could scan it, or I guess you can't scan here. You could import here.
And that would carry over to the.
Yeah.
Okay.
Yep. So once you set that up, all the mapping information where your vials are in the grid or the task order, then in real life, the users would go to the machine and execute the assay, and then they could come back and mark this as completed and add results. So this opens up a results batch editor. All the vials are here with your BSI IDs and your current labels. So locations are here, and if you're importing and you have the locations in the import file, it will normalize if you have hyphens, or I think if there's slashes as well, so or no hyphens. So this format isn't rigid. Your controls are set up here. If you had standards maps, that would be here, and any of the mixed information is here as well. Okay, so and our error here for our control is already showing us that the control is not within range. So hopefully, once we add data, that will be an acceptable value. And so this is our table that we set up with the Invader Analysis HPV, where we have each row representing one vial, and then each column is a different piece of information. The second data set that we added, which was a grid, is in a different tab. So we have the grid as a grid, or trying to think of a better word than grid or table, but it's showing as it was set up in our import file at the bottom. So how it would look as similar to the Excel file as it could be. And then we also show it in a table version as well. So with the location, the BSI ID, current label, control standards, and mix next to it. So we can see it in the simplest format that it came from, or in a way with more information that would help us utilize the data a little bit better. So this data can be imported. You could type in data here too, but the way that these files have been as scenes, you would want to import that. So the importer is similar to the standard importer, just with a little bit extra fluff and stats here. So you can select your file and press next. And the extra features that we have here are a preview of the import, and you can select different pieces to import. So if I want to import this property, I can select it, right-click, and say select import property, and I can select my run property that this is. So this is my data file date stamp, and it shows me data file date stamp. It shows me that value here as one of my run properties, just a preview of what I'm doing, so I am aware. And then I'll import my operator, and this is my raw data file name. Okay. So that's all imported at the bottom here. Then I can import my table information. So I'll select all my rows and import table. I'm going to use my first line as a header, and this import, the mapping and the property setting are in the same page, so you can choose to skip rows and use the first line as header. If this were a text file, there would be the text import properties at the top, and you can also do your mapping here as well. So this is all done in the same screen. And then next, I'm going to match on my PSI ID, and that shows my data in the table at the bottom here. Okay, so then for my color grid, I can select this and import my grid, and everything's fine here, so just import, and that's all set at the bottom. So that was with all of this flexibility for how you can import things. It takes a little bit more time if you're importing multiple tables worth of data and different properties. So you can save this, and I have it saved as the Invader import. And what that does is it saves all of the stuff that you just did. So anytime you select that you're using the Invader import settings, what it would do with the file, it would know that whatever you have in this cell here is going to be your data file date stamp. And whatever you have in this cell is going to be your operator. And this cell is this field, and row 5 through 101 is going to be your first table, and so on. And it just, once you load that in, it automatically maps and matches everything for you, so you don't have to do that. So then you press import, and that pulls in all of your data. All of our errors are triggered here. So these are all less than 1.5, which is what I had set up. So once it's saved, you have your results batch with your results data. If you wanted to then execute this with a new set of vials, you could do that through the through a requisition, and you would select, of course, your procedure. And if you wanted to add this to the same batch, you could enter in your results batch. And then once that's executed, that would be added as a separate run here. So I'm just going to manually show how that would look. So this can be our run 2. And this is right now an empty grid because I haven't pulled it. I haven't executed this with any actual files. But this could be imported, or if I were coming from a requisition, it would add in my next run as the new run in this drop-down. So you can switch between different runs within the same batch. And then for reporting, in the display fields, you can look at your results fields or your run data tables or your data set tables. So the data set tables are the ones that actually hold the information for each of the files or each specimen that the task was executed on. So you can add those to your display fields, and you should be able to join this with the vial table to at least see the BSI ID. But you could then search by the BSI ID, or if you're looking for particular values, maybe red signal is between 5 and 7, and you want to see all the vials that are returned by that, you could run that report, and that would pull up your vial data along with the results data. And then you could add in the requisition that it was done in, or different information just to pull it all together.